Okay, with this next section right here, we're going to have our special right triangles. We're going to have 30, 60, 90, and 45, 45, 90 triangles. So let me draw a right triangle here. I'm going to draw a generic one. Well, I was trying to. Okay. No. Doesn't like my triangles. Okay. So let's say that this is a 30, and then this last angle here would need to be 60, and then of course the 90-degree right triangle right there. You need to know your ratios of your sides. Okay, so whatever this side is, we'll call it S. The side across from the 60 is S times square root of 3. And then this, the hypotenuse side, or the side across from the right angle, will be 2 times S. So we're going to go ahead and use those ratios here on this first problem right here. The way I like to approach these here is write S square root of 3 across from the implied 60 degrees right there. So that means S right here, or this side right here, is going to be 6 right there, because if S square root of 3 equals 6 square root of 3, you can basically say this, the square root of 3's cancel. If you were to write it out as an equation like this, you could also just say, hey, both of these square root of 3's are going to cancel. So regardless of what way you think about it, you're going to get 6 for side Y. And then the hypotenuse side is always 2 times S, so I'm going to go 2 times 6 here for X, and that's going to get us 12. So really, you kind of need to go and find the Y part before you can do the X. And that's kind of the big idea with 30, 60, 90 triangles. Some of them are a little bit more advanced, but this one was a pretty straightforward one right here. All right, the other type of triangle that we learned ratios for was a 45, 45, 90 triangle. Basically, this is an isosceles right triangle right here. So let me draw the generic one for this. So this one here, whatever your two sides are, they'll be isosceles, right? They'll be the same. And then that means this last side here is going to be S times square root of 2. Now, if you're going backwards, if you're going from S squared of 2 to S, you need to divide. But in this case here, this first one here, we can put our S right there, which means S is 5. That means this other side, or this side Y right here, must also be 5. And then X must be 5 square root of 2. So some of them are that easy, and you're going to use one of these two special right triangles. What I suggest to you is when you get your test, draw these ratios out right away so you can refer back to. Okay, next one's going back to the 30, 60, 90. This time I gave you the short side, which we've been calling S. The side across from the implied the implied 60 degrees up there is S times square root of 3. So if S is 9, then we'll say this is 9 times square root of 3. All right, and then of course you got the right angle. That's going to be across from that your 2 times S. So 2 times 9 is going to be 18 units. So we got 18 and then 9 square root of 3. Okay, number 43, going back to the 45, 45, 90 triangles. And this time I gave you I think I was using L. Did I use S? Okay, I used S. Usually I use L, but it doesn't really matter. This is the square root of 2 side right here, and then these two sides down here at the bottom you can call S. So if you have S square root of 2 equals 4 square root of 2, you can basically cancel out the square root of 2's. Really, you do it by dividing, but regardless, you're going to get 4 for your side lengths here. So you can go 4 and 4 right there. So those are pretty straightforward there on that. Now, 44 is going to be kind of